Welcome back to Arcade. This is a series on creating a dungeon crawler in Phaser 3. I am Super Tommy, and in the last mini part, we went over fixing our drawing artifacts when we were scrolling around here by extruding our tile set using the tile extruder library you can find on GitHub. And so now we are going to create an enemy. It's going to move around randomly to give our game a little bit more variety so that we're not just walking around by ourselves in this game. It's very lonely. So we have taken, so we're using this tile set for the tiles. As you can see, this is from Itch, and we've taken one of these dudes. Can I do this green dude right here, and we've put them into a sprite atlas, just like our character is. So in enemies here, we've got lizard. And so we've taken his individual frames and put them into a sprite atlas using a texture packing tool. We went over doing that in part 2. So do check that out if you need to know how to do it. You can use Texture Packer, or you can use freetextpack.com that you can use to pack your textures into an atlas. So we're going to do something very similar as we did in part 2 for the main character, but we're going to do it for the enemy. And so let's close that out. And now we're going to preload our lizard atlas. This.load.atlas. We're going to call this lizard. We had this in enemies. I just have it memorized. It's enemies lizard. Let's just do that. Open it so I can see lizard.png and then enemies/lizard.json. Save it. There should be no errors. Good. And now go back to game. So first we're going to create the lizard, and then I think we're going to do some refactoring here because it's clogging up our create method and our game scene in general. So let's just say we're going to make a lizard, this.add.sprite. Let's say we put him at x 256, and y 256, and lizard, and then the starting frame. So lizard JSON. So just like the character before, the frame names are all here. And is there an idle? Or, oh, no, there. Yes, there's an idle. So idle 01. Let's just go with that. That is the frame name. So this should show up in our game. It does not. This 256 too far. Just making sure. Yep, there he is. 256 is too far. So that was on the Y 256. We'll just go Y 128. There he is. Just the picture of him standing there. So he's got a idle and a run animation. So just like we did up here, if you remember, this anims, we're going to do this.anims.create in very much the same way as we did for the character. We're going to call this lizard idle. Yep. He only has two, is idle and run, and it's going to just be side. So when he moves up and down, he doesn't turn. We just don't have assets for that for this character. So this.anims.generate frame names like before, and we're going to use the lizard texture atlas, and then we are going to start somewhere, end somewhere, and let's just check. So for lizard, we know we have 0, right? So for idle at least, F0. So let's just see. 1, F3, F2. So 0 is the min and 3 is the max. So 0, you don't have to actually look at the JSON for this. So when you create your texture atlas, you'll know you only had whatever your file names were, and so you would know. Since I've already made the texture atlas ahead of time, I'm going to check the JSON with the data to get this information. So same thing before, we have prefix, it's going to be some string, and then we have suffix, which is most likely going to be .png. And in this case, our prefix is this, right here. And then Phaser is going to throw in the number, or attach the number when it generates these frame names with the prefix and suffix and the number from 0 to 3, inclusive. So we want repeat. This lizard's idle has a repeat because it is a looping animation, and then a frame rate. I'm just going to go 10. I think he has much less frames. And now what we're going to do is play it. So lizard.anims.play lizard-idle. Look at him, bounce, bounce, bounce. 10 may even be too fast, but we're going to leave it. Next, we're going to make his run animation. So we just copy and paste and then change the particulars. So lizard run. And then let's just go here. What is the other animation? Run anim. So it's this. Let's just see how many frames this is. So 0 was smallest and 3 was biggest. That's the prefix, mrun, png 03. Good. Let's change this and we should see him use the run animation. Look at him. That looks pretty good. He's running. And just like before, we're actually going to want him to be a physics sprite. So you see we have this physics debug box around our main character, but we will want our lizard to also have a physics debug box. So that's him. Or it wants to have a collision box, so we can see it in the debug. Okay, so now we need him to actually move around. Now you see this is getting a little bit out of hand. There's a lot of code here, and it's getting a little bit messy. So what we're going to do is make a lizard class first to keep all our lizard logic in one place, and then we'll come back either in this video or a next video, depending on how long this goes, to refactor the character code. Okay, so we're going to make a new folder called enemies. It's under source, just for organization purposes. We could put it inside scene or anywhere else really. But to organize, we're going to put this under enemies, lizard.ts. So first thing, import phaser from phaser, because we are going to extend our lizard class from extends phaser.physics.arcade.sprite. And then let's do a constructor and figure out what we need when we look at super, what does TypeScript VS Code tell us? Scene XY texture frame. Okay, so we know we're going to do that basically. I'm writing this backwards only because then I can reference to put in what in the constructor. So this is going to be phaser scene. X is a number, Y is a number, texture is a string, and then frame is optional and is a string or number. Okay, so that's that. Cool. And now we also know that we're going to have multiple lizards. So when we go to game here, we can create a group, but let's do this first. Let's put this anims code somewhere else. Now, one where you would perhaps think first offhand is to stick it into the lizard class. However, the anims manager is global, and so you only need to edit animations one time, not for every single lizard. So you don't need to do it every time a new lizard is created. Instead, what we're going to do, I'm going to make another folder here. We're going to call this anims, and we're going to call this enemy anims.ts, and we're going to make a function called create. We just say create lizard anims, and it's going to take in the animation manager. So once again, we're going to import phaser from phaser just for the typing. Phaser dot animation manager, and we may need more, but for now we'll just leave that as is. And we're going to take this code, I'm going to copy that, paste it in here, and we don't need this .anims, we just need anims. because we're going to pass anims in, and we're going to then run this code in this function. This all looks good. Okay, now let's export create lizard anims. Okay, let's go back into game here. Import anims, enemy anims, and this create lizard anims. So you see we did something similar with debug draw. If you remember, we moved our debug drawing logic into its own function so that we don't clog up the game scene. So we can delete this and replace it with create lizard anims, this.anims. Right now, in fact, you can do this way up here, even before everything else. Shouldn't matter. You can create the lizard anims. We can actually do all our animations like this. All right, so that still works. We can do the same thing, and let's just do it. We're going to do this for character. So character anims. Same deal as we have before, just before. Import phaser. We're going to make this function called create character anims. It's going to take in the animation manager, which is phaser.animations.animation manager, and let's collapse this. We're going to take this stuff right here, take it out of there, put it into this function right here, and in VS Code, if you highlight like this, just drag select it, and then you press Command or Control D if you're on Windows, I believe, it'll pick them all. So now this is the multi-cursor selection, multi-selection, something like that. Now I can delete them all at once. Ta-da! Save me a bunch of time. Instead of doing it one at a time, it's what computers are good for, really, saving you time. If you know how to use them, I guess. Anims, character anims, and now let's just import it like we did before. Create. I did not export, right? I missed exporting, yes. So you must export your function for it to be importable. And let's go back here, create, okay. Come up here, we'll just create the character animations first. It doesn't actually matter. Okay, now let's make sure everything still works. But you see our create is now much smaller. And everything still works. And we've now shrunk our create method to right here. Much smaller, much more readable, less room for error. So that's good. So now we've got our lizard class made. And what we can do is put this in our lizard class, right? So that when we make a lizard, we automatically switch to an animation, in this case, probably idle. So we know we're going to have more than one lizard, realistically. So we can make a lizard group. So we'll call this lizards, and it's going to be this.physics.add.group. Because we want a group of arcade physics sprites. Well, yeah, so we need a group of sprites that have physics bodies. So, but we are going to give it a different class type because it's going to be lizard, and VS Code will auto import this. If for some reason it doesn't auto import, you just got to do this. It's using this shortcut, but so to do absolute path, this will be relative path. So it works no matter what system you're working in, what environment you're doing. So this is the lizard class imported automatically by VS Code if it's not, do it yourself. And we're gonna, so here we specify the class type for this physics group. And let's comment this out, probably delete. So lizards dot get. So same thing, let's get a 256, 128 lizard, just like that. And then we should get the same lizard on the same spot. And there he is. And this is from the lizard class, right? We are automatically playing idle here. As you can see, we got rid of this, as commented. And we can show for sure by changing this from idle, this is his bouncing idle, to run. right? And see, now he's run. So we are successfully using this lizard class that we made, which is excellent. Now he needs to move randomly, right? That's what we want him to do. That's the simplest thing to do right now. There's obvious different AI logic you can develop, but we're going to do random. And so let's see, how should we make that work? So first, we're going to use pre-update, which just like update and scene takes or passes in a time and delta time into the parameter list. We're first going to call super, and we're going to give it not super, super dot pre-update. We want to call the parent implementation of pre-update. There's probably things that it needs to do in the physics.arcade.sprite class, the implementation of that class. So we call super to let that do its thing, and then we're going to do our own logic. And so we want the lizard to move either left, right, up, or down. And so we're going to make an enum here. So this is a TypeScript feature only. We're going to call this direction. If you're using modern JavaScript, create a bunch of consts that match this. So for example, we're going to do up, down, left, right. You can just make const up, const down, const left, const right, either as 0 to 3 or as strings. In TypeScript, these will be numbers by default, right? Yes, so this is 0 and this is 3. Okay, and we're going to give our lizard here a starting direction, and it's going to be direction dot, let's say direction dot right. Okay, and now in the update, let's do a switch here. Based on the direction, we're going to do some logic. So case direction dot up. So if up, that means this dot body dot set velocity. Okay, there's this dot set velocity means no x and then minus some amount of speed. I'm going to just put this here. You could in fact make this a class property. It may be better that way. Probably. We'll do this for now. We can always change it. Case direction dot down break. And if we're going down, we're not going negative, we're going positive speed. And then if left, we are going nothing on y and minus speed on the left break. Case direction dot right, and it's going to be speed and 0 for right break. Okay, so it's going to do that given the direction. Let's just see what this does. It should move right and pass the screen, and because it's not colliding, let's just do that real fast because we need to, I like to keep my collider adding together. We just bring this down here. We need to give it a collider. So dot collider lizards and walls. So now our lizard should just move right and stop. Yep. Okay. So we can, so when it hits a wall, we should probably change direction as well as randomly over time. So let's think here. There is a collision event. Let me see if I can remember what it is. Now I'll show you in the docs what it's supposed to be. Let's see. Right, okay, so let's go here. Where are we? We're gonna go physics. Let's do this. So there is an event that you can get on the physics world when a collision happens. So physics.arcade.tile collide. So when something collides with a tile, Phaser dispatches this event right here, and you listen to it like this. And what it gives you is the game object that hit the tile, and then the tile that was hit, and then the body of the game object involved in the collision, which you can always get from here as well. So we're going to do this. Scene.physics.world.on, and it's going to be phaser.physics. So phaser.events physics. No. You could just say tile collide, and maybe that's fine, but I do prefer to use the consts when possible. I missed it. Physics.arcade. Okay. Phaser.physics.arcade.events.tile collide. And let's make a private method here, handle tile collision. And what we're going to get is the game object, phaser.gameObjects.gameObject, the tile, phaser.get tile maps dot tile, and body probably don't actually need, so we'll just leave that out. This dot handle tile collision, and then we have a context, which is going to be this in this case. If you do want to know how that works, the scope and context inside Phaser, there's a video we have called JavaScript Scopes and Context Explained in the context of Phaser. Do go check that out. I will link it in the description below. Okay, so we have that. So now what we're going to do is if go not equal to this, so if you know, it could be multiple things colliding. If it's not us that's colliding, we don't care, and we're not going to handle it, we're not going to do anything. But if it is us that collided with the tile, we want to change direction. So we have here, we know, okay, so you do want ints for your direction. This goes, we're going to randomly pick a new direction based on these directions here, 0 to 3. So new direction is going to be phaser.math.between, and it's going to be between 0 and 3 inclusive. And then we're going to go this dot direction new, new direction. So when our dude here hits it, we should, yes. So there is another part of this. I'm not sure if the docs actually mentioned this. Yes, it did. So the game object has to have its onCollide property set to true. So this dot on the body rather. I think there is actually no body at this point. So this will probably error. Let's just check. Yes. So in this constructor, it has not been added to the physics world yet. So there is a few ways to fix this. There is an event that we can listen to, but as well, I believe there is a create callback. And I believe the create callback gives me the game object. Yep. We can see. Go in here. If you're using Visual Studio Code and using the type definitions, you can do this. And that is only one thing, the item. Okay. And so there, okay. So what we know is that Go is a lizard, since we're specifying class type here. And then we can do lizgo dot body dot onCollide true. So this will make sure when in the group, when it's creating these new lizards, that it will set onCollide to true. So now let's save that. And now our lizard should change direction when it hits the wall, and there it goes. So every time the lizard hits the wall, it's going to change direction. So we're coming up to about 25 minutes. We're going to do one more thing, and that is that this is not totally perfect, right? You can see that if it was going right, you can still randomly get right again, but it will handle the collision again and then change. So we're just going to do something real quick here. Call this random direction, and it's going to take exclude, a direction to exclude. And then we're going to generate a random direction here that is not going to be anything passed in here, just one. We can just take one direction, not an array of directions. You could do that yourself. And it's going to be mostly the same, right? So let's say I'm going to start with this. We're going to do let. You can do this recursively as well, but we're going to do this in a while loop. So while new direction is for some reason is randomly equal to the exclude direction, we are going to generate another one. And until that is not true, we're going to keep doing that. Or until while this is true, we're going to keep doing it. And then when that is not true, we're going to return the new direction. Now, of course, theoretically, you can have an infinite loop if random always returns the same thing that you're excluding. So you could add a little count here that don't do this more than 10 times. At 10 times break, we're going to leave it. It's nearly impossible for that to actually happen here. And so what we're going to do, delete this, and we're going to say random direction, and we're going to exclude the previous or the current value of direction. So there we go. It's going to move, and you see it's going. Fantastic. Now, we also, okay, one more thing. We also want the lizard to change direction randomly, not only when it hits a wall. So we're going to do this dot, not this, scene dot time. This is the time, I think the clock on the scene. Is that what time is? Is the, yeah, phaser dot time dot clock. And we can do event, add event. It takes a config, and it's going to be a looping thing that calls something. So we want it to loop. Okay, so delay. So let's just say in our case here, every 2 seconds, we're going to hit a callback, and that callback is going to do something, and it's going to repeat. Is there a loop? Yeah, loop. True, forever. And it's going to return us a event. So we're actually going to save this because we need to clean this up, right? So we're going to save this as, just call this move events. And what is that of type? Phaser.time, the timer event, .time.timer event. And I'm going to do this dot. Okay. And what the callback is going to do is just this. So we're going to change direction randomly every 200 milliseconds or every 2 seconds. And right, so that's how the lizard's going to move, not only when it hits a wall. Now let's just save that. So we're going to follow. Okay, so see, he's just going to change direction without hitting any walls, right? So now he's moving randomly, and he will also change direction when he hits walls. So that is good. Now we saved this move event because we have to clean this up. Otherwise, you're going to have this looping event forever. And in some place, certainly in the case when you leave the scene, it's going to still go, and your some things may no longer be in memory anymore, and you can have some problems. So we're going to clean this up by overriding the destroy method. And always got to call the parent destroy. And so let's actually take that as well and pass that down. Okay. Now we want this dot move event itself needs to be destroyed. Okay. That's our cleanup. And it should be important to note that we do all of our destruction, all of our cleanup, and then we call the parents destroy. Versus here, we have the parent do its update, and then we do our update. It's just a better practice in case we destroy, or in case the parent destroys something that we actually need to clean up. So it's sort of an inverse out on destroy. So you do your thing first, then you let the parent handle it. Okay, so that's destroy. We've got it cleaned up. This is now 30 minutes. I think we are good here. In the next video, we're going to add collision between our character and our enemy and add some health to the character so that you can actually die.